going to be whenever something is decreasing in value. And one of my, actually first we need to do this, then I'm going to tell you about one of my favorite applications of this. So this is the same slide you guys had the other day, but we're going to fill it in again so that we make sure, like, you need to really, really, really know this, okay? Exponential growth or decay formula. What is the A value in that formula? It's your starting, or sometimes you'll see the word initial amount of whatever you're talking about. Might be money, might be bacteria, might be population, whatever. But it's what you start with. Okay? Your B is your growth or decay factor. It is not the straight growth or decay rate. We'll see that in a second. It's the growth or decay factor. You got to do a little work to get the B there. All right. And then X is always going to be some sort of time. It might be years, it might be months, it might be days. I think on the notes that I gave you guys yesterday, I only used years on those problems. We'll see a couple today that are not years for that. And then for this, yesterday you only looked at growth. So for your B value, you would do 1 plus your rate as a decimal. Okay? For decay, we are going to do 1 minus the rate as a decimal. You can kind of think of growth being like the sales tax that we did, where you take 100, you add the 7%, you move your decimal 2 places. Growth is like a sales tax scenario. Decay is like the discount scenario. So if something is 30% off, it would be 70% on. So that's similar here. Okay. So my favorite example to use for this is something that may already be applicable to you right now. Is there anybody in here that has their own car payment and actually pays their own car payment? Caitlin and Abby. And the rest of you guys are getting old enough that you will probably in the next 5 to 10 years of your life be purchasing a car of your own that you're paying for with your money and not your parents' money at some point. So one thing I like to stress to students here is that when you buy a vehicle, what is going to happen to the value of that vehicle? It depreciates. It goes down. Yeah, as soon as you drive off the lot, it starts dropping. Right now, there have been some weird times around COVID with like supply and used vehicles, but I think that's about to ease off too. In general, when you buy a car, it is, and if you drive it, it is only going to decrease in value. There might be some exceptions for like classic cars that you don't really drive. You just sit it in the garage and rub on it a little bit. They might go up in value the older they get. But what we're talking about here is cars you drive every day. They are going to go down in value. Some people will say their car is an investment. Hunter was watching The Office the other day, and Michael Scott said that his car was an investment. So it's a terrible investment if that's what you're going to invest your money in, because it's not going to go up. Things like houses typically go up in value as long as you don't destroy the house or let the roof go bad or something like that. Land typically goes up in value. Some things do typically go up in value. My husband claims that guitars go up in value, which does sometimes happen, but I think it is mostly his excuse to buy more of them. But some things will go up in value. Cars are not one of them. So as soon as you drive it off the lot, it starts dropping, right? And I've kind of messed up this problem. We're going to change that 2018 to 2024, or else this is a question that is a silly question to answer. They've already told it to you in the problem, right? So if Manny buys a new car for $28,750 in 2018, the car is going to depreciate by 12% per year. Now, that 12%, I'm just making up these problems. They seem like reasonable numbers to me, but that's going to depend a lot on what type of vehicle you buy. Some of them hold their value better than others. It's going to depend on the condition. So if you put a ton of miles on it versus not as many miles, that might change. If you take good care of it, that might increase it. If your 7-year-old leaves slime in the seat of your vehicle, that's not going to do anything good for that depreciation value there in that case. So it's going to start dropping. And so what happens here is it's like 12% per year. So let's look at this equation, then we're going to look at it on Desmos to kind of picture what's happening to it. So the way that we do decay problems is we're still going to have y equals, and we have our starting value. So for this, that's $28,750. Okay? Now for our B value right here, we're going to do 1 minus our rate as a decimal. What is 12% as a decimal? 0.12. And then when we subtract that, we should get 0.88. So that's the number that we're going to put right here for our B value. If it's decay, that number should be less than 1. Question, Eddie? Do you feel like the 0.12 should go there? That's the biggest mistake most people make. So it's like the discount, although it's, it's a value situation, but like if something is 12% off, it will be 88% on. That's the part of the value that the vehicle retains. So we're not multiplying it by the part that it's losing. We're multiplying it by the part that it keeps, right? So it loses 12%, but it keeps 88% of its value, if you want to look at it in the positive lights there. And then we'll... Yes, if it appreciates, so if it was something that was gaining value, if it says appreciates, you would have 1 plus the 0.12. But when it depreciates, we're decreasing there. Okay, we good here? All right, so we are going to plug in, or first let's think about what this stands for. X. What do you guys think that X is going to stand for? It's a time, and for this particular case, what time are we using? It's years. We are going to use the 6. Yes, we are going to use the 6 to answer the question. But just for what it stands for, it's years. And then this Y right here, what's that going to stand for? You could use the f of x for it. It's your value of the car. What's your question, Eddie? Is it related to this?
If you type it just like that, but for the x, put 6.
Yeah, it's going to give you an answer.
And then in the parentheses, you put 0.12 minus 1. That's the root.
Yeah, it'll work.
Oh, yeah, that's right.
Yep, that'll work. Oh. Okay, so I'm going to graph this first. Now, some of you are already plugging that 6 in, and that is how you get the answer. You're right about that. But I want to think about this so you can, picture it. Now, if I try to graph it, I got nothing, especially if I've hit the house button, right? And if I zoom out, I can see the graph now. Is this the part of the graph that I want to see? Because X is years. Do I need to know how much this car is going to be worth in 500 years? You were planning on living longer than I'm going to make it. And having a car that makes it a lot longer than I'll make it. 100 is a ridiculous amount of time to look at this equation for, right? Even if you buy a brand new car, if you get 30 years out of it, that would be remarkable, right? Your mechanicking skills are high if you've got 30 years out of a car. So if you zoom out, you will be able to see the graph, but it's probably not going to be the most helpful graph. So if everybody will go to Desmos, type this in. I don't even have it on. Everybody go to Desmos. I want you guys trying it. I'm on. didn't have my class wise on. I'm probably watching the YouTubes. Alright. Everybody get your Desmos. Type in this equation. I want everybody with me right now to make sure you can graph this so we can see it in a helpful way, right? Not just zooming out. Because what I usually find is kids just zoom in and out. And sometimes that works pretty well. And sometimes it gives you a terrible graph that does not help you answer the questions. So in this case, what I've got on my x-axis is fairly reasonable, like 10 years. You know, most people do usually like keep a car 10 or less years and then get a new one, right? Because it starts to get a little bit worn down after that. Some people will stretch it further. But that's fairly reasonable. My x's are fine. It is the y's that I need to be much bigger. So if you will go over here and hit the wrench button over here in the corner. So go to the wrench. The only thing we need is we need a much bigger y value. How big do we need it to be? What's
10,000, 5,000.
I'd go higher than 20.
30.
I'd do about 30, or you could do 28,750. That's as high as the car's ever going to be, but I'm going to just do 30,000. Right? There is my graph, and then you can zoom in and out a little bit from there. This is a helpful graph, right? Because I might have this car for up to 20 years, but I'm not going to have it 500 years from now, right? So everybody look and see. I'm going to check on my Desmos, see if you got on here. Look, get a graph. Check your neighbor. If theirs doesn't look good, if they don't have it, show them how to do it. Students can't answer these questions just because they don't get it seems right. Okay, I think you zoomed out. You hit the house button first. There. Alright, then go change just that, like top Y value. Right here, change that. Not right there. That'll be like oh, you have 6 in here. That make it X. Alright, set the graph. Alright, yours is not that. Alright, hit the wrench, go right there. Change that number by 30,000. Okay, got it. Alright, check it. Okay, you need to sit over here where you can see better. Okay. Okay, we'll plug you in into the, we'll get you plugged in somewhere. Come on back over this way, Lucas. In fact, let's see. Lucas, can you see from that seat right there? Or you can see it there? Okay. Yeah. Come on over here.
Right here, on the Y values, I'm at 30,000.
Let's see, I haven't got to this side. Okay, the graph.
Right there's when you bought it.
Okay.
10 years.
So let's see, yours is not great.
Are you good? You good?
You had like a zoom, and then it just makes it look like a pig. So, hit the house button. There. Alright, now go here. I think you changed it. Alright, that is the length. That is not what we changed. Right here. That number changed.
We'll get cell service.
Okay, it is because you like zoomed out. Hit the house button first, it'll get it back to like the normal. Then hit the wrench button. And then go change that number right there to like 30,000. So where you had already zoomed, your X's were really, really big. If you hit the house, it'll get you back.
when you bought the car, where it crosses the line, and then every year it keeps going down, down, down. 10 years, that's what it's going to be.
Then change that.
Yep, right there.
Get rid of those ones. Now, just go back over here. Okay, you can zoom a little angle, but if you're having to like zoom a bunch, it's going to distort the graph. Okay. All right. So, now I know I'm taking a long time on this problem, but I think this stuff is important. So if you look, whenever they bought this car, it was worth $28,000. It's right there. So 1 year later, it has dropped to $25,397. 25 and a little bit, right? So from the time you bought it to a year later, you've dropped about $3,000, right? But then the next year, you're going from like 25 something to here, 22. If we did the math, it's dropped a little bit less, but still almost $3,000, right? Here at the beginning, that graph is steeper, right? Your value is just dropping fast. Now, if you look out here, let's say you keep it for 10 years, right? If you keep it for 10 years, it's only worth about $8,000 at this point, okay? But if you go to the next year, 11,000, or 11 years, you're a little over $7,000, so it drops about $1,000, right? So at the beginning, you were dropping like $3,000 every year. But out here, when it's 10 years old, it's only dropping like $1,000. And then if we were to go over here, like if you keep this thing 20 years, you got that baby for 20 years, it's worth $2,000. But then the next year, 21 years, it's worth $19,600 and $1,969. You lost $30 worth of value in that year, right? So these are really important things to consider when you're buying a vehicle. In my opinion, if your parents are buying you a brand new, spanking new vehicle right at 16, then you really are something there. But if you buy an older car, it's not going to drop as quickly, right? In value, because it's already kind of old. Now, it also might not be reliable, so you got to consider that as well. How many of you ever heard of being upside down on the loan? Anybody ever heard that phrase, like somebody's upside down on the loan? All right, this is a teaching moment for you guys.
Negative.
So if you buy this car, and this is not the greatest example. This happens more on expensive vehicles with long loans. Welcome back. Let me give you your. All right, so this happens on expensive vehicles with long loans, when you don't give much of a down payment. So if you go buy a $90,000, like, let's say a $90,000 like Suburban with everything on it, the nicest you can find, and you drive it off the lot, it is going to drop. And you have financed this, you had almost no down payment, you financed it for a long time. Maybe a year later, the vehicle might be worth $80,000. But you might still owe the bank $85,000, depending on what your payments are. I'm just throwing numbers out there. I'd have to run them to know exactly what would happen here. But if you have a vehicle, you could sell it for $80,000. So if you decided you're done with this one, you want to sell it, you could get $80,000 for that vehicle. But you owe the bank $85,000. So you owe the bank more than the car is worth. Okay? So what happens if you total it? Your fault, somebody else's fault. You got full coverage insurance on it. What happens if you total the vehicle? How much is insurance going to give you for the vehicle? How much is worth? They're going to give you $80,000. and you can take that $80,000, you can pay the bank. How much do you owe the bank? 85. So when you give them your $80,000 for insurance, you still owe them $5,000, right? But you got nothing. You don't have a car anymore. It's been destroyed, right? So you would still have to pay that $5,000 even though you don't even have the car anymore. So that's kind of what it means to be upside down on a loan. You owe more on the car than the car is even actually worth. As long as you don't wreck it and eventually get it down, it will be okay. But when this happens is in these first few years right here. It happens in the first few years. They'll try to sell you insurance on that too. You'll have like gap insurance, which costs money to have and you might not even need, because as long as you don't wreck the vehicle, eventually you'll get caught up, right? But you are running that risk. It's the same too if you like trade something in when you owe more on it than it's actually worth. They're not going to give you as much for trade-in. The bank will be glad to let you roll that over into your next loan, and before you know it, you owe. I know we had a buddy one time that I think owed like $20,000 on a truck that might be worth $12,000 because he kept rolling over loans into different things. So there are several ways you can avoid being upside down on a loan, because it happens right here. It happens in these first few years. So one way to avoid it is buy something that's used anyway. It doesn't drop as fast, right? That will help. Your best and most surefire way to avoid it is to pay cash for the vehicle. But that would mean that you've got to have all the money up front. Then you don't have to get paid any interest. It saves you a lot of money. It's a great thing to do if you can come up with the money ahead of time. Not the easiest to do. But if you buy something used, it's not going to do this as badly. If you do buy something, if you put a down payment on it. So if you save, I would highly suggest save up $5,000, $10,000 to pay first. And then you only owe a smaller amount. The car's worth more than you owe on that. Yeah, it makes your payments a lot less as well for that. So you can also, now this will make your payments more, but if you do a shorter term loan, if you only like finance it for 3 years, it's going to make your payments high, but you're paying it off really quickly, so you'll be on top of things. You won't really need that gap insurance on there, and you'll have it paid off a lot more quickly. You'll be paying a lot more each month, but it'll be over with before you know it. So that's all advice for your future car buying future, because one day you will probably all need that unless you're going to walk. Bicycle. Around here, it's going to be hard to pull off. There are places you could do without a car for sure, but not in rural America very easily. You're going to need probably a way to get around. So this is all exponential decay sort of stuff. Really important stuff to think about. Now, I still haven't even answered the question. Answering the question is way easier than my lecture on your financial future here. What do we need to know in this particular case?
The value
After 6 years, where am I going to plug that 6 in?
where the X is.
Where the X is. Let me show you two options you've got over here on Desmos. You can do one of two things. You can go down here to the next line and say X equals 6. It will put you a line right here. You'll see it's $13,351.62. Or you can go up here and type in that 6. It gives you the number right here. Or you don't have to have the Y equals if you do it that way, but it will graph it. So you don't necessarily need to see the graph. I was just trying to explain what's happening right here. So we got $13,351.62 is our answer for that. What was it? 62. Is that what it was? I need to split screen again so you can see it. Yeah. So, you'd still have a car 6 years, but your car's worth less than half than it was whenever you paid for it. So, if it is your investment, it's a bad investment, but we all have to have them to get around, so it's necessary there. All right, now 2 is almost the same problem. Mark buys a brand new car for $35,000 in 2008. If the car depreciates in value approximately 8% each year, in what year will the value of the car first drop below $15,000? Okay, so we still have definitely the price of the car and the amount that's depreciating are different. What else is different about this problem? It's going to affect how we have to do it. What do you think, Abby? It's asking for you to look, see like how long it takes to drop, right? The other problem wanted the value of the car. This one is asking for time. So how we do it's going to be a little bit different, but we still set the equation up the same. So whenever I look at this, let's see, Jacob, what's my initial value going to be for this problem? 35,000. So 35,000. Okay. Then I have to come up with my B value. So Zachariah, what am I going to do for that B value there? Okay, I need to use the 0.08, but I don't put it like right here, right? That's not what I do with it. What have I got to do? It doesn't let me erase anymore. We do 1 minus that. So we're going to do 1 minus 0.08, and that is going to give me 0.92. So that's the number that goes here. Sorry about that. It doesn't let me erase for some reason. Something's wrong. And then we'll have to X power here. And so for this, I like to put this here. X still stands for years here. Y still stands for the value of the car. So when I plug in 15,000, which is what it's asking me about, where does it go? Which variable do I put it in for? The Y, not the X this time. So if I do that, it would look like this. 15,000 equals 3,500 times, 35,000 times 0.92 to the X power. But we actually should know how to solve that. You can use a log, divide by 3,500, use a log to solve it. You could do it by hand. But they let us use Desmos on everything. So I'm not going to put us through that unless you just want to do it that way. So what I'm going to do here to solve this, instead of trying to solve it by hand, I'm just going to put my equation in. Y equals 35,000 times 0.92 to the X power. Okay, so everybody make sure you got that in. And my view is still pretty good. If yours is not, you might need to adjust it. Everybody put that in. I want to know when the car is worth 15,000. I want to know when Y is 15,000. So what should I do on the second line? Y equals 15,000. And it will put a line here for me. And I'm just going to see where they cross. And it's 10.162. So it's 10.162 years. Now that's not really the answer to the question. Because the question says in what year. It will not be in the year 10, right? It'll be 10 years from when we started. Right. So we'll take 2008 and we'll add the 10, technically 0.162. We don't usually really do that. It's going to be during 2018. Yeah, during 2018. Sometimes the question will be like, how long does it take? And then you could answer it with the 10. If it says in what year, it's looking for that year of the car, not the number of years. Okay, so those are very similar in setup, but just a little different in how you solve them. Okay, questions? Okay, next problem. These are also really important. Super duper important. Maybe not that everybody needs to do this, but it's going to be really important for some people. Now, Bryce is going to take 400 milligrams of ibuprofen. His body processes the medicine at a rate of 30% per hour. How many milligrams of ibuprofen are in his system after 4 hours? So if Bryce takes some ibuprofen because this math is giving him a headache and he can't take it anymore, so if he takes some ibuprofen, 400 milligrams is your dose of ibuprofen you're supposed to take. It's 2 pills. It's what, the box tells you to take. All right. If Bryce has the biggest headache of his life because of all of this math, and he takes 3 ibuprofen, is he immediately going to have major problems from that? Probably not. I am certainly not suggesting that you take a higher dose. But many people have survived it before. Now, the reason they have that on that box is because if Bryce takes 3 ibuprofen today, just one time, probably not going to have a huge effect on him. If Bryce takes 3 ibuprofen every 4 hours for 4 months, yeah, that is probably not going to be good for him. And if he does it for years, we might be looking at like liver failure kind of problems, right? So over time, it would be very bad. So that's why those are there. But it would take a while for ibuprofen to have that effect. However, if you go to the hospital because you have to have some sort of surgery, what are the people called that put you to sleep? Anesthesiologists. How long do anesthesiologists have to go to school? Like 12 years or something crazy. Like forever. Yeah. Really long time. Yeah.
I don't sleep every day.
For surgery. To medically put you to sleep for surgery. Yeah, so you have to go to school forever. Anesthesiologists also make a ton of money. Ton of money. But the reason is because they are giving you drugs that could easily kill you. Easily. Whenever I had to have just like a small like outpatient procedure done, and the doctor before I had to have it done told me they're going to use, I can't remember the name of the drug, they're going to use this to put you to sleep. And then he said it was Michael Jackson's drug of choice. This did not make me feel better, because what happened to Michael Jackson? He died on this drug, right? Because he took too much of it. So that does not make you feel better when they're about to give you this drug, right? And thankfully, the guy knew what he was doing. I'm still here today. I survived. And most people that have surgery do. But the anesthesiologist is giving you medicine that could easily kill you. Because they have got to, to put you under, they are giving you something really strong. Or if they don't give you enough, what happens? You wake up in the middle of surgery. Yeah. Yeah, sometimes people are allergic to it, and then it gets really complicated, too. It's a good thing they have to go to school forever, and they deserve every penny that they make. I could teach you guys every bit of this wrong right now. I could teach you the opposite of what you're supposed to do. And you will still be alive tomorrow, and your life will be only minimally impacted by that. But anesthesiologists have a lot on the line, right? So they need to be. And a lot of what they're doing is math. Like, they need to know exactly how much you weigh. They need to know all these different specs on all these different medicines, interactions between medicines, differences between whether the patient's male or female can make a difference, like all kinds of family history, all kinds of things they got to consider. So I do not want somebody who barely made it through Math 3 to be my anesthesiologist, right? I want somebody that can do this stuff in their sleep, and those people usually are that type of person, right? So because a lot is on the line. Bryce and his ibuprofen, this is not going to be so critical, but the same thing happens even whenever you're talking about super high stakes sort of medicine. So this can be critical down to the decimal point in a lot of places. So you have to, it's really important. And if you have a new medicine that you're researching, they had to decide at some point that 400 milligrams of ibuprofen would be safe for people to take, right? Because it doesn't tell you that if you only weigh 90 pounds versus weighing 300 pounds, how much to take, but there's a difference there. They have to give a dose that's going to be safe for most people to take. Some drugs have a much bigger safety margin, like ibuprofen, where, if you take 3, it's probably not going to be the end of the world, although it might not be good for you long term. versus something like the medicines they use to put you to sleep. There's not as big of a safety margin. Yeah, well, yeah, Benadryl. Benadryl has a high safety margin, I think. But
like, if I take like 2 Benadryl, like I'm not gonna wake up.
yeah, it will make you go to sleep for sure.
I'm probably gonna be asleep for like 6 hours.
Yeah, I would not recommend that. I do not know the answer to that question. Yeah, nobody doing fentanyl is carefully calculating their dosage for the, nobody doing illegal fentanyl now there is like a medical version of that they kind of use, so like they might use it in the hospital, and if they need to give you fentanyl in the hospital because you're in like massive amounts of pain from a major car wreck, they're monitoring that closely. But if you get some fentanyl on the street, this is why it's so deadly.
That's dangerous.
It's so deadly. Because nobody's calculating that, but they should be, because it's,
That's
yeah.
gonna kill you.
yeah, like easily kill you.
Wow.
And lots of people die from it. So, and of course, for your drug warning of the day, you don't know if it's in there or not. You might think you're getting something else and it might have it in there. So don't do drugs, kids. Narcan will, but you gotta have it. And I wouldn't gamble with it. I would steer clear. Yeah. Not right now. We'll get them later. But that's one of the things. Like they can give you like a medical equivalent of fentanyl in the hospital, and people are okay. But people that take it on the street are not sitting down and carefully calculating how much they should take, right? And you know that it's not good. There. So after that life lesson, let's do this problem. The problem itself is not all that bad to do. What should we do? Y equals 400. What should I use as my B value?
30%.
1 minus 0.30, which is going to give me 0.7 or 70%. That's the percent that stays in your system. And then we'll have an X here. I've finally given you one that does not have does not have years as your X value. This X right here this time is hours. And then the Y would be the amount of ibuprofen remaining. Okay. So what do we need to do if we want to know after 4 hours? Just plug in 4. So we're going to have 400 times 0.7 to the 4th power, 96.04. So after 4 hours, you'd have 96.04 milligrams in your system. You start with 400 milligrams, so you have 96 left after 4 hours. Question, Eddie?
So his body processes the medicine at 30% an hour.
Mm-hmm.
So every hour he would get 30% of those 400 milligrams. Right?
Yeah, 30% is being like used up, so 70% would remain. Like I think ibuprofen is mostly your liver that's processing it. So like your liver is like filtering out 30%, but you still have a 70% in your bloodstream. So like if I make a table with this, Eddie, like if I do, let's see, I think I know how to do this. Like if I do 400 times 0.7 to the x1 power right here. Like, so at 0, you'd have 400, right? After 1 hour, it's down to 280. That's 70% of what you started with. Okay? Then in the next hour, you'd have 196. That's 70% of 280, right? And then in the third hour, it'd be down to 137.2. That's 70% of 196. So it's like the car loan. It drops a little less over time.
So it's based on the number before.
Right. So like that 496.04 is 70% of 137. Like if I do 96.04 divided by 137.2, it gives me 7.7%.
I thought it was going to be like, so 4 hours, that would be 90%. So 90% of 400 would be 360. I thought that's...
No. It's the like hour before it. Yeah. This is also like how, if you were to ingest an illegal drug, because like if you look at, if we look at our graph right here, if I graph it, and let's see, we need to go back down here to like, this one, let's go like 400. So if I go like to here, it's less and less and less and less. So like way out here at 15 hours, how much is left? 1.872, right? It's like as far as its effects, it's basically nothing. But it might still be detectable. So that is why if you were to go ingest an illegal substance over the weekend, and then you get called for drug testing, even a couple weeks later, right? There's still tiny, tiny trace amounts in your body. You're obviously not high anymore or having the effects of it, but it would still be detectable. So that's why they can catch it on drug testing, even if you're like not under the influence at the time. Like if you're like whenever they do like breathalyzers for drunk driving, that's your at the moment test. But drug tests can test for much further out.
That makes sense.
Yeah.
When someone's hiking, it's like the
Yeah, a lot of times they have red. That's nice. Yeah, so Eddie.
I'm not.
Yeah, hope not.
Probably.
That'd be a problem. Okay, so that's all related to this. All right, the last one here is the hardest one that we're going to do here. This is a half-life. Here's another application. Now, this is something that would be more scientific, right? You're going to look at this. Certainly, if you're dealing with radioactive substances, they decay in a certain way. It needs to be studied. I made this problem up. It's not a real radioactive substance, but there are ones that behave in the same manner, okay? So, half-life of a radioactive substance is 7 hours. If a scientist has an initial sample of 600 milligrams of the substance, how long will it take until there's only 5 milligrams left? Okay? So in this case, I'm going to have Y equals, what's the starting amount? 600. Okay? What do I use for my percentage here?
Half.
It's not the 7 hours. That's the time. It's not the 5 grams. That's like, we want to know when we get to it. There's no percentage in this problem, is there?
Okay, so half-life is the amount of time that the initial quantity will take to get to half of it, right?
Correct.
So if the half-life is 7 hours, then 7 hours divided by 300, something like that.
All right, so like, if you understand what half-life is, it means that like, if you start off with 600, after 7 hours, you'd have 300, right? And then after 14 hours, you'd have 150. And after 21 hours, so like every 7 hours, it's cutting it in half, right? So that'd be 75, right? And if I change my graph to where we can see it better, let's make that go up to 600. And actually, let me make
Also,
mine.
it keeps splitting instead of just steady rate.
Yeah. So, like, you can kind of see what's happening here. It's dropping. If I go to the next one, at 28 hours, I would be at, what's half of 75? 32.5, I think. And so it just keeps, like, dropping half and half and half. Much like our drugs, our car value, it it's leveling out, right? It's getting lower and lower and lower. It doesn't ever actually get to 0. All right. So it never gets to 0. Every 7 hours, we're cutting this in half. So there's no number like 30% was in the last problem, but there is a word that tells you a percentage. What is that word? Half. What percentage do we use for half? 50%. And so this is the only time that it doesn't matter whether you do 1 minus or just use the percent. Because if you do 1 minus 50%, what do you get? You get 0.5 again, right? So you get 50%. So 0.5 is the number you're going to use here for those half-life problems. And then we'll have an X power. Now, there is a tricky part to this. This does not stand for the number of hours in this case. It's the number of half-lives. And then this is your amount remaining. All right, so if we look at this problem, if I graph it, y equals 600 times 0.5 to the x value, I'm going to go change my house and change that to 600 here, okay? So you can see that this is dropping here, okay? I want to know how long until 5 milligrams are left. So where do I plug that 5 in? It gets plugged in for the y, right? So that 5 milligrams is an amount of substance left. So it gets plugged in for the y. How do I do that over here on Desmos? Perfect. Y equals 5. Oh, we're going to have to zoom in a little bit there. Okay, what are we getting? 6.907. All right, so 6.907 hours. Does that sound right? Think about that table I made a minute ago. At 7 hours, we were at 150. Or not 150, 300. So I don't think this is in hours. What did we say our X stood for? So it is 6.907 half-lives. But normally, we don't answer a question in number of half-lives, right? We were like, that wouldn't really make a lot of sense. How long is a half-life for this? 7 hours. So it's 6.907 7-hour periods. So we need to multiply our answer by 7 hours to get the actual number of hours. So if we take 6.907 and multiply it by 7, we're going to get 48.349. 48.349 hours. Yeah, so just over 2 days. All right. Okay, we are a little bit